Welcome. Now we discuss the solutions of 2023 question papers DSE-B1 only Laplace transform part. This is the question paper 2023 DSE-B1. We only solved the Laplace transform part. The English version is first question. Question 1G. Laplace transform of e to the power at minus 1 by a. The correct option is 1. Because this is the Laplace transform of this is 1 by a by linearity property. Laplace transform of e to the power at minus 1 by a Laplace transform 1 is equal to 1 by a 1 by s minus a minus 1 by a into 1 by s. So after simplification we get 1 by s into s minus a. Question 1h. Laplace transform of t into e to the power 2t. Correct option is 3. Laplace transform of e to the power 2t equal to 1 by s minus 2 is greater than 2. And since Laplace transform of t to the power n ft equal to minus 1 to the power n f small f nth derivative of s. So this t, here t is power is 1, so minus 1 to the power n and f dash s. So minus dds of 1 by s minus 2, that is equal to 1 by s minus 2 square. So correct option is 3. Question I. Inverse Laplace transform of 1 by s square minus 8s plus 17. Its correct option is this 3. We write this s minus 4 whole square plus 1 square, and this equals to e to the power 40 sine t, because L inverse 1 by a square plus a square equal to sine 80 by a, and L inverse small fs minus a equal to e to the power 80 capital Ft. This is the first shifting property. So we get the correct option is 3. Next question from Laplace transform, question D. Find the value of Laplace transform of sine 70 plus 5. Question 2D. Sine 70 plus 5 is equal to sine t cos 5 sine a cos b, sine a plus b sine a cos b plus cos a sine b. So this cos 5 is constant and sine 5 is constant. So the bilinearity property cos 5 L of sine 70 plus sine 5 L of cos 70. And so sine 80, Laplace transform of sine 80 is equal to a by a square plus a square. This is greater than 0. So this is equal to 7 by a square plus 7 square. And cos 70 is equal to cos 80 equal to s by a square plus a square is greater than 0. S by a square plus 7 square. So after simplification we get 7 cos 5 plus s sin 5 by a square plus 49. Next question, question 2e. And the value of L inverse 1 by s bracket a square plus 1 bracket close. L inverse 1 by a square plus a square equal to sin inverse 80 by a. So L inverse 1 by a square plus 1 square, that is 1, equal to sin t. Also L inverse fs by s is equal to integration 0 to t capital F u du. So this is equal to 0 to t sin u du. So minus cos u, limit from 0 to t, that is cos t minus 1 and 1 minus cos t. This is the answer. Next question. Question 1e, question 3, 3e part 1. Evaluate Laplace transform this e to the power minus bt sin at by t. Question 3e, 3 part I. This evaluate this. Now sin it equal to a by a square plus a square, and Laplace transform of e to the power bt f t equal to small f s minus b. So e to the power L of e to the power minus bt sin it equal to a by s plus b whole square plus a square. So L of capital F t by t equal to integration s to infinity f u du. Hence this integration s to infinity a by u plus b whole square plus a square into du. And this is a constant, and this 1 by a tan inverse u plus b by a s to limit infinity. You can write this limit capital A tends to infinity, that is capital A. This is the pi by 2 tan inverse infinity and tan inverse s plus b by a, that is equal to cot inverse s plus b by a. The answer. Question 3e part 2. Evaluate L inverse 1 by a square into s plus 1 where L of f t equal to capital Fs. Now L inverse 1 by s square equal to t, L inverse 1 by s plus 1 equal to e to the power minus t. So L inverse 1 by s square bracket s plus 1 is equal to integration 0 to t u into e to the power minus t bracket minus bracket t minus u du by convolution theorem. So this integration with respect to du, so t is constant, so e to the power minus t constant, so 0 to t u into e to the power u, and by parts integration and gives this limit 0 to t, and after put here first t u equal to t here, and then u equal to 0, so we get the result t minus 1 plus e to the power minus t. Question 3f1. Find the Laplace transform of the function ft where ft equal to 0, piecewise function, this 0 less than t less than equal to 1, t 1 less than t less than equal to 2, and 0 t greater than 2. Laplace transform ft equal to integration 0 to infinity e to the power minus st ft in dt. That is 0 to 1 integration 1 to 2 and 2 to infinity. So when 0 to 1 function is 0, when 2 to infinity function is 0, so only we have integration 1 to 2 e to the power minus st into t dt. This is the integration, this into this integration minus integration of 1 to t, and the derivative of this, that is 1, and again integration this by parts this, we get the answer is this e to the power minus s bracket 1 by s plus 1 by s square minus e to the power minus 2s bracket 2 by s plus 1 by s square. Question 3f2. Using Laplace transform, solve the differential equation d2y dx square minus 2 dy dx plus y equal to 0, given that this is the boundary condition of y0 equal to 0 and y1 equal to 2. Taking the Laplace transform on the both sides of the equation 1, given equation, we get L inverse L y double dash minus 2 L inverse y L y dash plus L of y equal to 0. So a square y bar s, this is the y bar, means the Laplace transform yt is equal to y bar s, say, minus s into y0 minus y dash 0 minus 2 into s y bar s minus y0 plus y bar s equals to 0. So put the given boundary conditions y0 equal to 0, so y0 equal to 0 and y dash 0 equal to c, say, assuming y dash 0 equal to c, and we get this. So y bar which is a function of s, this equals to minus c equal to 0. So y bar equal to c by a square minus twice s plus 1. So the Laplace inverse Laplace transform of y bar, that is equal to yt, is equal to c into inverse Laplace transform 1 by whole divided by a square minus twice s plus 1. So this equals to L inverse 1 by s minus 1 whole square, and the first shifting property c to the power t L inverse 1 by s square, that is equal to ct to the power t. Now from the boundary equation y1 equal to 2, so these two I put y1, so t equal to 1, put t equal to 1, so we get this equal to 2 equal to c into 1 to the power 1, so c equal to 2 by e. Put this value of c in this equation 1, in the equation 1 we get yt equal to 2 by e t to the power t, that is equal to 2t to the power t minus 1, and this is the answer. The solution of the given differential equation, particular solution is this. Question 3G1. Evaluate L inverse 1 divided by a square plus 1 bracket into bracket a square plus 9. L inverse 1 by a square plus 1 into a square plus 9. We can write this L inverse 1 by 8, 1 by a square plus 1 minus 1 by a square plus 9. So by linearity property 1 by 8 common, L inverse 1 by a square plus 1 square minus L inverse into 1 by a square plus 3 square. So this equals to sine inverse sine t, because L inverse 1 by a square plus is equal to sine 80 by a. So this is by 1 and this by sine 3t by 3, and this is the answer of this L inverse. Question 3G2. Using Laplace transform, solve the differential equation d2y dx square plus 3 dy dx plus 2y equal to the power minus t, given that y0 equal to 0 equal to y dash 0. Question 3G. Let Laplace transform of yx is equal to y bar s. Given equation y double dash plus 3y dash plus twice y equal to e to the power minus t, e to the power minus t. Actually, this is the x. So actually we write here, actually this is the function of x. So this is the x in place of t. Otherwise, okay, this is L inverse y double dash 3 into L inverse y dash plus 2 into L of yx, L of e to the power minus x, e to the power x. So this equals to a square L of ys minus s y0 minus y dash 0 for this L of y double dash plus 3 into L of y dash equal to s L of y minus y0 plus 2 into ys is equal to 1 by s plus 1. So the simplification we get this y0 equal to 0 and y dash 0 equal to 0. It is given from the initial condition this. So the simplification we can write y bar s equals to 1 by s plus 1 into s square plus 3s plus 2, that is equal to s plus 1 into s plus 2. So s plus 1 whole square into s plus 2. And by using the partial fraction, we can write this equal to a by this s plus 2 plus b by s plus 1 plus c by s plus 1 whole square. And comparing the coefficients with the this we could, from both sides we get a plus b equal to 0 and twice a plus 3b plus c equal to 0. and a plus 2b plus 2c equal to 1, and we get the value of a equal to 1, b equal to minus 1, c equal to 1. And so we put this value a equal to 1 and b equal to minus 1 and c equal to 1. So we get L inverse 1 by s plus 2 minus L inverse 1 by s plus 1 plus L inverse 1 by s plus 1 whole square. So we get e to the power minus 2x minus e to the power minus x plus e to the power minus x, L inverse 1 by s by first shifting property for this. So this equals to e to the power minus x into x. So this is the answer, e to the power minus 2x minus e to the power minus x plus e to the power minus x into x. And this is the answer, that solution, a particular solution of the given differential equation. So we get 4 plus 16, 4 plus 16 and 5 plus 5, 10, so 30. Question number 3, any 4 question. So question 3, we get 30 marks, only touching the Laplace transform. And from question 2, we get 5 plus 5, 10. So total 40, 40 plus, this is the 1 into 10. So we get 1 to 10. So from small question, MCQ question, we get only 2. So out of 65, you can easily get 40 to 42 marks from the chapter of Laplace transform. Thank you for watching this video.